Hello, algebra students. Mr. Lawrence here, and here's your fourth review video. So far, nobody sent me any special videos on how to do something. By the way, I will post this one. This is Sunday night. It's getting posted. I know it's a day late, but I was very busy Friday and Saturday. And also, I don't want to post the Chapter 9 video until after the take-home test is due. So I'll post that Monday. It'll still give you time to ask me questions about it in class on Tuesday. All right. So let's get down to this. Chapter 8, first of all, we start with polynomials. We have to know how to name them. Now remember, polynomials to degree 1, when there's no variable, are called linear polynomials. And this should be total review. You should be an ace at this by now. Second degree are called quadratic, right? Quadratic. Third degree are cubic. And then fourth degree, of course, are quartic. Okay, you should have made flashcards about these a long time ago. You should have them memorized. This should be total review. If there's one term, and a term must be a variable, if it's not a variable, we just call it a constant. But if there's one term with a variable in it, we just call it a monomial. Monomial. Right? Two terms in it, we call it a binomial. Binomial. And three terms, we call it a trinomial. And then, of course, after three terms, we call it a polynomial. Oh, by the way, if it's higher than degree 4, we just use the number of the degree. So if it's x to the 5th power, we would call it a degree 5, whatever, monomial, binomial, depending on what it was. All right, so that's that. I don't want to go over that too much, take too much of your time up. That should be simple stuff. All right, we had operations with polynomials, and sometimes we added them. And remember, I suggested that you do some kind of system to highlight. For example, I'm going to make my x to the 5ths yellow, right? Okay. I'll make my x cubes green. And notice I grabbed the sign. There's another green one. Okay, my x squareds are going to be blue. And I grab the sign. Always grab the sign. Okay, there's no blue one in the other quantity. We'll do purple for my constants. And I don't really need to highlight that 4x to the 4th term because not being highlighted could count as a color of highlighting, right? You see what I'm saying? All right, the yellows combined would give me 9x to the 5th. The greens combined, oh, I want to go in order, descending order, 4x to the 4th. And then my x cubes, I think I'll get a negative 2x cubed. All right, there's only one blue term, so I don't have to combine it with anything. It just comes along for the ride. And then finally, my constants gets me a negative 2, and there you go. Now, some of you can do that awesome, and then you don't stop to think on the next problem. You see it's subtraction? You can't just subtract the first two terms. You have to subtract all the second quantity from the first quantity. Well, what you do is you distribute a negative 1. See the negative 1 there? Yeah, you can always insert a 1. It doesn't hurt anything. So I multiply all three terms by negative 1. So what my problem becomes is 10x cubed minus 5x squared plus 7x, and then I'll have a minus 4x cubed, a minus 5x squared, and a minus 3x. Had one of those terms in the second quantity been negative, it would have changed to a positive, right? All right, so let me highlight my x cubed terms. There we go. I think I know what those are going to make when I combine them. My x squared terms are here. See, some of you thought they were going to cancel. They're not. They're not going to cancel because they're both negative. And we're just adding or subtracting. So let's see here. Let me get back to my pen. And so 10x cubed minus 4x cubed is 6x cubed. My green ones get me a negative 5x squared, and a negative 5x squared give me a negative 10x squared. And the blue ones get me a positive 4x. All right, down here on the next one, you've got two choices. You can double distribute, which I like to call it, where I multiply those two. And then I multiply these two. Or you could FOIL. Okay, I'm not going to demonstrate foiling. If you know how to FOIL, that's awesome. You go ahead and do it. So I'm going to get a 15x squared, right? 5x times 3x plus a 10x. And then I'm going to have a negative 21x. And I'm a vertical kind of guy. I like to do my addition and subtraction vertically. So I wrote it underneath. Then a minus 14. And when I do it this way, I don't need the highlighter. I'm just going to add things up. 15x squared minus 11x minus 14. Hey, by the way, this quadratic trinomial, yeah, that'd be a quadratic trinomial, right, is factorable. And if I factor it, I better get these two quantities as the answer. All right, now down here I have a binomial times a trinomial. I have a linear binomial, right, 6x plus 2, and a cubic trinomial. Well, again, we have to double distribute. Now, you can't use FOIL on this one because you don't have enough letters in FOIL. FOIL only accounts for 4 multiplications. So another reason I don't like doing it that way. I like to do it a way that allows me to use the technique no matter what my problem. All right. And there we go. So I'm going to multiply the, uh-oh, I lost my pen. As Jarrett Dietrich would say, my famous highlighter, airliner, excuse me. 6x times 5x cubed will be 30x to the 4th. And then 6x times negative 4x squared will be a negative 24x cubed. And then 6x times 3x will be an 18x. Okay, I'm going to have a 2x times a 5x cubed will be a 10x cubed. So positive 10x cubed. All right, a 2 times a negative 4x squared. Oh, do I have a mistake? Yeah, I have a mistake. This should be an 18x squared, shouldn't it? Okay, a 2 times a negative 4x squared will be a negative 8x squared. And 2 times 3x will be 6x. And again, I don't need a highlighter when I do it this way. I can just line them up vertically and combine like terms. So 30x to the 4th. How many x cubes will I have? Well, negative 14x cubes. I'll have positive 10x squareds and a 6x. All right, that's it for operations. Now, the one section that some of you still haven't mastered is factoring. And I'm sorry to say you're running out of time. You're going to see lots of factoring on the final, and if you don't choose to not learn it, well, there's really nothing I can do. All right, so the GCF, a common mistake many of you are making, you only find the GCF of the 12 and the 16. You must find the GCF of the variables as well. Of course, the GCF of the 12 and 16 is a 4. Well, what's the GCF of the variables? Well, I think it's going to be an x cubed, right? Because each of them have at least 3 x's being multiplied together. So I'm going to factor out a 4x cubed, and then I'm going to get a 3 minus a 4x squared. Now, this cannot be factored anymore. A lot of times when we factor out a GCF, it makes things simpler so that we can factor more easily later on. This one will not be able to be factored, okay? Now, we should always try GCF on every problem first, okay? If we're trying to factor binomials, we look for the GCF. If we only find a GCF of 1, there's only one way we can factor, and that's by the difference of perfect squares. That's the only way. But what does difference mean? Difference means subtract. If you don't see one negative after you factored out a GCF, you can't factor it. This second problem here, 9x squared plus 16, this is prime. It cannot be factored. Okay, if it was equal to 0 and you were trying to solve it using the quadratic formula, it could have solutions. It just can't be factored. And actually, this one would have only imaginary solutions. But this problem here is prime. If you check the discriminant, you will not get a perfect square. I don't believe. No, you'll get a negative. Yeah. Okay. Now, this one here, we have a perfect square minus a perfect square. What's the square root of 25x squared? Well, it's going to be 5x. And what's the square root of 16? It's going to be 4. So we're going to have 5x plus 4 and 5x minus 4. If you have a binomial, there's only two types of factorings that can work with it. One is GCF. Doesn't mean it will have a GCF other than one, but that's one type that could work. And then two, the difference of perfect squares. Other than that, you can't factor a binomial any other way. What happens when you have a trinomial? Well, the first thing I do is I check to see if I have two perfect squares, if A and C are perfect squares. And here we have a 3x, and over here we have an 8. I like that because they're both perfect squares. 9x squared and 64 are perfect squares. Now I multiply them together and get 24x. If I double that, do I get B? Yes, I do. Then I have a perfect square trinomial, and this factors as 3x, 8, and a 3x, and an 8. Now remember, the C term is positive. That means both signs are the same. What sign do I use? I use B's sign. B is negative. They're both negative. Now, some of you will like to write it like this. And that, of course, means the same thing, just that quantity squared. All right. What happens if they're not perfect squares? Like in this case, x squared is a perfect square, but 12 certainly is not. First, I'm going to check the discriminant. Now, I notice some kids not doing the square, the b squared part of the discriminant. You have to do the b squared part. If you only do b or ignore b altogether, you will not get the right solution. All right, so I'm checking the discriminant. I'm going to get 16 plus 48, and I believe that'll equal 64. And 64 is a perfect square, so this will factor. So I'm going to put a 1 and a 1. I'm going to slap x's on them because I'm Hannah Dawson. She likes to slap those x's on there, so she puts them in the right place later. I normally don't do that, but I do think it's an intelligent idea because it allows Hannah to correct a mistake that she might have made or prevent a mistake that she might have made. All right, I've got my factors of 12 listed. I'm going to subtract after I multiply. How do I know I'm going to subtract? Because C is negative. And I want to subtract to get negative 4. Oh, I see it already. I'm going to do 1x times 6. And I'm going to do 1x times 2. So that's going to get me a positive 2 and a negative 6. Because when I combine those, I'll get a negative 4. So here's how I factor. Two quantities, right? My x terms lead both quantities. So I'm going to have an x and an x. You can put the ones in there if you want. And then I do my little loop and my big loop. So let's see, this x here goes to the 2, and it's positive, and the other x goes to the 6, and it's negative, and there you go. That is completely factored. Now, when a is 1, all this work isn't quite necessary. I just showed all the work for those of you that are having a little bit of trouble. All right, let's check this one out here. Let's see. Well, 6x squared is definitely not a perfect square. Let's check the discriminant. So I'm going to do negative 11 squared minus 4ac. And so I'm going to get 121 plus 240, which is going to be 361, which I believe the square root of that is 19. And so this is a perfect square. So I can factor. So I'm going to list the factors of 1 and 6. Oh, I'm sorry, I have 6, 2, and 3. And the factors of 10 are 1 and 10, and 2 and 5. I'm going to multiply factors together, one of the factors from 6 and one of the factors from 10. I'm going to subtract them, because C is negative, to get negative 11. Let's see here. Ooh, I think I've got it. I've got a 3 times a 5, which is a 15. A 2 times a 2, which is 4. Now I want negative 11, so I'm going to make a negative 15 and a positive 4. I am ready to factor. So here I go. my 2 and 3 lead the quantities, but they will have x's on them, right? Because they're factors of 6x squared, not of 6. So I'll do a 2x and a 3x, and I'll do my little loop and my big loop. And so the 2 got multiplied by a 2, right? Follow the red loop there. So this loop ends up with a 2. It'll be a positive. And the little loop is going to get a 5 because 3 gets multiplied by 5. And I noticed the 15 was negative, so I'll make the 5 negative. And there you go. It's factored. That is the only way to factor it, by the way. I mean, of course, you could have the quantity of 3x plus 2 times quantity of 2x minus 5, where you change the order of the quantities, but that is the only way to factor. All right, one more here. I've already checked the discriminant. I'm not going to bore you with that. It is factorable. If I had a discriminant that was not a perfect square, a negative or a number, a positive number that's not a perfect square, I would go ahead and tell you that the expression is prime, assuming that I had checked the GCF. I had pulled out a GCF. Was not able to pull out a GCF other than 1. Okay, so I'm listing all my factors here. Try to get a few more factors. 1 and 18, 2 and 9, and then 3 and 6. Now, I notice that C is positive this time. So when I multiply my factors together, I'm going to add. I'm going to add to get negative 39. So in other words, I'm going to add 2 negative numbers together. Well, let's see. How about 3 times 5 is 15. And if you remember, I said I wanted to add 2 negatives together. And 4 times 6 is negative 24. And when I combine those, I get negative 39. So I am ready to factor this. This is going to factor as a 4x and a 5x. Got to do my little loop and my big loop. And let me see here. The 5 gets multiplied by a 3, right? So I need a 3 there, and it's negative. And the 4 gets multiplied by a 6. That's a 6, and it's negative, and there you go. All right, that's it for the video. Now, if you really need help factoring, of course, I'm helping after school Monday. And don't forget about that other factoring video, the one from a little while ago. It's on BrunswickTube and YouTube. It's really well done. It goes in much more detail. All right, that's it. Mr. Lawrence signing off. Have a good night, everybody.